All right, good afternoon, everybody. Welcome to the MachineMetrics webinar, How to Prepare Your Shop Floor for IIoT. Let's see. Today, the presenters are me. I'm Eric Fogg, co-founder and chief customer officer at MachineMetrics. And today we have my other co-founder, Jacob Lauzier, our CTO.
Thanks for having me.
So today we'll do a quick overview of MachineMetrics, and then we'll dive into the content. The key takeaway that we hope you have today is that preparing your shop to implement IIoT is much easier than you probably think. We've done a lot of work to make that very easy. I hope to show you a few ways that we do that today. All right, so who are we? We are based in Massachusetts. We're a cloud-based machine connectivity platform. Got a few hundred customers all around the world. Well over 5,000 machines connected at this point. We're a venture-backed firm with an engineering organization spread out all across the country. You can see a sampling of some of our customers down at the bottom of the list here. We offer multiple scalable solutions on our platform, everything from tracking just basic utilization. Are your machines running? Are they not? When are they running versus when do you want them to be running? Condition monitoring, tracking temperatures, pressures, flow rates, vibration. Can track all of that within our product, look at it historically, and set alerts if a particular sensor or spec goes too high or too low. Send out a text message, set out an email alert, set off an alarm. Lots of functionality there. Production monitoring, we track how many parts your machining assets make versus how many you expect them to make, and break down in lots of charts and reporting exactly why you are or are not hitting your goals. And we do tool monitoring, so we can tell you if your tools are getting dull, when it's time to change tools, when it's time to maybe inspect or replace wear components on your machines. So getting into the content here, preparing your shop for a system like this. I think the biggest thing to tackle first is a change management question. A lot of shops we've learned over the past 9 or so years of doing this might be ready as far as technology goes, but not quite ready as far as company culture goes, because this is a big shift. This is going from being a much more hands-on, on the floor, walking around and talking to people sort of management paradigm to being a lot more data-driven, working on problems as they show up in the product. So a big question or complaint we often get from especially operators on the floor when we're talking about the system is it feels kind of like Big Brother. We're tracking how much their machines are running, how many parts they're producing, what alarms and issues those machines are having along the way. Sometimes people on the floor feel like that's a little bit intrusive into their job and into their life. So I think there's some simple ways to have conversations around that with your employees. And the difference between what we see our customers' employees feel is either Big Brother or a large help, something that makes their life easier, is really the tone around the conversation that you have when the data surfaces issues and problems on the floor. So instead of on the floor when there's a big problem, going out on the floor and saying, what the heck's going on? What went wrong? What did you do wrong? Say, hey, we noticed that this machine has fallen behind a bit this shift. Tell me about what's happening. How can we help make your life easier, get this machine running again, get this process running again? We found once you start having those conversations on the floor with the employees, their response and their feeling, their attitude towards a system like this really starts to change a lot, because they realize the data that this system is surfacing is not going to be used to get me in trouble. It's just going to be used to help me. And if that's the narrative that you have on the shop floor, if you're just kind of casting a positive spin on the data that you're acting upon, we've found and seen tremendous cultural changes at our customers, and the whole shop floor starts to really come together around the data and around finding solutions. One way that it makes a big difference, and I think back on when I was a machine operator, when problems get pushed out on the timeline a lot. So if you're struggling for a week and you don't have a conversation with your boss or the engineer about that problem until Friday, it's really hard to talk specifics. And oftentimes those conversations turn into excuses, scapegoating, confusion. And I personally remember those conversations and never leaving them feeling really great or feeling confident in myself as a machine operator. But we found when you take the conversation to, as soon as the problem happened, the alarm pops up on the machine, or the machine falls behind on production for an hour or for a couple hours, and you talk to them, it doesn't feel urgent. So the excuses don't really happen, the scapegoating doesn't really happen, and there's not a lot of confusion there because you can look at exactly what happened on the machine, you can look at the data, and you can have a conversation around it. Another item that I think is really important to talk about with your team when you're implementing a system like this is that it's 2023 and we need to be digitally driven. And for business to stay competitive, this is something that needs to happen. So the old way may have been, more relaxed or something like that in some ways. But at the end of the day, there are jobs that need to get done, parts that need to be delivered to customers in a competitive way. And having your pulse on the data of the shop and understanding what's going on much quicker is a big part of staying competitive. So machine adapters. So we get all this data. How do we get it from the machines? And there's a lot of different ways that we can pull data from machines. MachineMetrics has built a lot of different adapters for particular machine controls. But a lot of machine controls use standard adapter schemes. Some of you may have heard of some of these on this slide: MP Connect, OPCUA, Ethernet IP, industry standard data protocols. So a big thing for getting your shop ready for IoT is making sure that these protocols are enabled on your machines. Some of them may require just a little bit of setup. Some machine builders sell it as an option. So Mazak and Okuma, companies like that. You can call up your sales rep with those companies and order the MP Connect option. And they'll send you usually just a little thumb drive and the instructions on how to install that option and get it enabled for your machines. So before you implement and kick off the system, you need to make sure that you understand what machines need what protocols. We can help you do that. We have a process in place. So you can send us what we call a factory assessment, which lists all of your machines and the controls. And then we'll go through that and let you know exactly how each machine will best talk to our platform and what steps you need to take to either order these options or enable them. If you run a lot of custom machines, so say it's an Allen Bradley controlled assembly station or a custom piece of automation, something like that. A lot of those PLCs have data protocol that we can pull data from, but we don't know what that data is because it's a custom machine. So we need something called a data map, which basically tells us the data that's coming off of the machine. What does it mean? When a particular output on that PLC is open, what is it turning on or off? Once we have that data map, we can pull all that data into MachineMetrics, and then you can use all of our tools to understand it live and in real time. We can also connect to older machines, machines that don't have a data protocol that we can talk to over Ethernet or serial or Modbus. And we call that an IO integration. So those integrations are actually just hooking into some simple circuits on the machine to understand, is it in cycle, has it made parts, or anything else you want to track. So if you have older machines that will need an IO connection, the first thing to do is decide what data from that machine is useful for you. It may just be in cycle and part count, but you may want to add something like a temperature sensor or a vibration sensor or a light curtain to count parts that are good versus bad. Really, the sky's the limit on what you can connect. We're really only limited by the availability and the cost of the sensors. And sensors are getting pretty cheap these days. For a few $100, you can get temperature, pressure, vibration, those sorts of things from the machines in a very robust and dependable way. Another step would be to gather the schematics for the machine and review those. So if we're looking for a relay in the machine's cabinet that clicks every time a part is made, we'll need the schematic to understand what relay that is to connect to and understand exactly how to connect to it. So once we've gathered all that information, we know what you want to connect to. You can install or you can discuss the installation with either MachineMetrics or if you're using a third-party system integrator. And we can either walk you through how to do it yourself, provide you all the documentation so you can do the install yourself. We can send one of our own technicians on site to do that install, or we can work with a third party of your choosing to do that install. Next is physical networking. So the first question that comes up is, can we do a wireless network across our shop floor? So we don't have to drop Ethernet cables to each machine. That can be a problem sometimes because ceilings are high, production floors are busy, it's hard to get a lift in there to run Ethernet cable, all of that. And the answer is yes, we do support wireless systems, but we've generally found that they're more trouble than they're worth. Wireless on a manufacturing shop floor can be really difficult. There's a lot of interference from different machines, from welding operations, things like that can provide or can create a lot of broad spectrum interference that can knock machines off of a wireless network. So to do wireless successfully, we found you have to implement a really robust set of wireless access points on your shop floor, of commercial or industrial grade wireless access points. And generally, we've found that the price to install those is similar or sometimes even more than the price to just pull Ethernet cable, which is very reliable. So most of our customers choose to just run Ethernet cable to each machine. We don't use a lot of bandwidth, so it's not like it needs to be a very expensive, Cat7 insulated shielded Ethernet cable. Pretty much any Cat5, Cat6 will do just fine for our uses. And you can see in this little diagram here, this is an optimal way that your network can be set up. So you set up a separate machine network. Ideally, you don't want your machines to have access to the internet. There's a lot of reasons for that. It can vary from machine to machine and the operating system that those machines have. But we generally like to guide our customers into creating a separate machine network. So you can have a switch that connects to all your machines, your IOs, your assets on the floor. And from that switch, we'll go into one port of the MachineMetrics edge device. That can be the edge device that you purchase from us, or it could be a virtual machine that you spin up using VMware or something like that. The second Ethernet connection on that edge device will then go out into your regular network where it has access to the internet. And basically our edge device here hosts all of the adapters. So it'll talk to all the machines and devices on the floor. And then using two different Ethernet connections, firewalls that machine network from the the internet connected network. And Jacob will go a little bit more into how to properly firewall that in just a minute. There are other ways to set up this network. You can set up VLAN. We can be pretty flexible, but it's pretty basic and doesn't require any additional expensive networking equipment. The last thing to consider is if you're using Ethernet already at your machines for DNC or for FTP, so sending and receiving programs or variables and things like that. If that machine is already on the network, we can either piggyback on that, or we can add just a simple like 5-port Ethernet switch at the machine to split that connection between the DNC and FTP connection to the control for programs and the monitoring connection to the control, because they're generally 2 separate Ethernet ports. All right, and with that, I will hand it over to Jacob.
Thanks, Eric. Yeah, there were a few things that I wanted to touch on the networking side. I'll get to that in a moment. But first off, I'd like to talk about platform extensibility. So as you're adopting a machine monitoring or IoT platform, you really want to make sure that the investment that you're putting in is going to return immediate value. It's a journey, right? This whole process is a journey, and there's lots of steps along the way. And we want to make sure that as you're adopting this and changing your internal processes, that each step is introducing some new value, so that you can kind of see that the money that you're putting in is giving you a return. So the product that you end up going doesn't have a $500,000 multi-million-dollar price tag. That is just a bunch of upfront custom work that somebody has to maintain on the other side. Hopefully it's got an actual application that you can use in addition to some things that we'll get to in a moment. So really having that upfront values is really important. It also needs to be tunable. Each shop is a little bit different. You have different cells, different groups, different types of equipment. The data points that you capture might not mean the same thing to you as it does to somebody else who has that similar piece of equipment. So being able to tune the data that you're getting from the machines for your use case, and then tune the overall system so that it meets your business needs is an important step as well. And then how can it be extended? It's not just that the product needs to have an application in the end. You should really work with your IT teams and anybody else that might be able to take the product and connect it into your other factory floor systems, and see how the data from machines can really be leveraged to drive other factory floor systems, and even extend the capabilities that are offered in a product like MachineMetrics to create a little bit of a digital moat of around your organization. It's a competitive advantage. Next slide, please. So this is an important part about that extensibility, and that's how do you take the machine data and allow it to enrich other business applications? And one great example of that is, what is the machine doing? What is it intending to be making right now? What part is it machining? And one thing that we found is that the program headers themselves, which we can get from most pieces of equipment, the program headers themselves contain a lot of really rich, detailed data about what part is being machined. And so with that, there is a step that you should undergo, and that's to assess your G-code lifecycle. How does the code get processed, managed, maintained, and then pushed out to your equipment? And where in that process can your ERP data be properly aligned into that? There's a disconnect, right? There's your ERPs, and then there's the engineering side, and often there's no real connection between the two other than the people that work in those different areas. And in order to automate a lot of these aspects of your business, there needs to be a digital link between those two. So start to think about how you can systematize the life cycle of your G code, so that the program headers, as one example, could be leveraged to tie your ERP into the machine data. Next slide, please. All right. So next up is there one before this? Yes, IT consideration. So this is speaking a bit to what Eric had gotten to earlier around IT versus OT networks. Your OT networks has all of your machine equipment on it. Most machine equipment, it works the way it works. And you're likely not seeing many of those machines' operating systems getting updated on a regular basis. There's security patches that should be applied to this equipment, but that often doesn't happen. So another approach that you can take is isolation. And for the most part, machines are isolated from the internet by not plugging them into a network at all. But in order to adopt an IoT strategy where you're getting data from these pieces of equipment, they do need to be interconnected in some way. So the approach that Eric laid out earlier starts to go down that path. Keeping the machine network segregated from an internet-bound network is your first defense. And our edge device can act as that bridge. It reaches out to the machine. The machine does not reach out to it. There's no firewall rules where you have to allow the cloud to interface with your internal systems. You could block the edge device from accessing arbitrary services and limit it down to just those that are required by whatever service that you're working with. And that's something that's fully documented and we can support you on. But there's no reason for you to open up ports so that the outside can reach in. And so allowing for this this IT network, internet bound, versus the OT network, machine side, to be segregated, you're going to protect your equipment. As you're working to identify the right IoT platform for yourself, think about software updates. Who applies the software updates? How often do you get them? Who's in charge of maintaining and supporting the product? We apply our software updates for our customers across the fleet. Everything stays up to date, security patches and so on. It's not something that our customers actually have to worry about. And then support and maintenance, it just comes along for the ride. We're constantly applying new fixes and new features that all of our customers are getting. So there's no surprise gotchas as time goes on, and the product continues to work and scale and be backed up regularly, continuously. Next, information security. This is a really important one, especially with the coming of the cybersecurity maturity model for customers that are in the government space. There are a number of different compliance programs that you may already be aware of or need to be aware of or already be participating in. Really start to understand those and what sort of data could be coming off the machine that you would consider sensitive. Earlier, we were talking about program data that identifies the part. Depending on how your organization operates, sometimes part numbers can include customer numbers. So really think about how you can start to segregate what's necessary for you to do business on an operational side versus what's necessary for you to do business on an accounting side, and see if that separation can be made, because that could be a good buffer between what might be considered classified information versus unclassified information. And then what certifications or solutions that you're using adopting. We've, over the last 9 years, have grown our security program because we really understand how our customers trust in us to house and operate a very important aspect of their business and integrate into many of their systems. So we go through rigorous penetration testing and security audits under the ISO 27001 standard and are constantly looking at new certification programs to adopt and test ourselves against. So that's a really important aspect when adopting an IoT platform, is to make sure that the data, the company that you're entrusting your data with has the right security posture, especially in the environment we're in. Great. We'll open it up for questions. Before we do that, while you're typing in your questions, I did want to let everyone know that after the call, we'll send out the recording. And we also have a webinar coming up on May 10th with Modern Machine Shop on multi-plant monitoring. So be sure to check in on that. Along with the recording, Eric and my contact information, which is displayed here on the screen, will also be included in there. Feel free to reach out if you have any questions, and share the recording with your colleagues. Appreciate that.
Great. Yeah, sorry, I had some trouble unmuting myself. The bar went away. So we had one question, Jacob. May the MM Gateway application run on a server or virtual machine?
Yes.
Could you elaborate on that a little more?
Yeah, I can touch in on what that is. So our edge software, our edge device is nothing special. It's an off the shelf. It's green. I guess that's special. It's nothing special from a hardware perspective. It's an x86 based PC, 32 gigs of storage, 64 gigs of storage, 4 gigs of RAM. You can provision a virtual machine to run that software, and we can provide that to you. You could also provision your own hardware if you had a physical device as well. Not many customers do that. They either go virtual or with our physical box. There's a lot of benefits to our box if you're doing the wireless case, because the device does buffer and forward. If it loses access to the internet temporarily, it will buffer the data before it transmits, so that you don't have any data loss. The virtual machine version of that does that as well, but you can't put a virtual machine in a CNC. Haven't figured that one out yet.
How powerful of a VM would somebody need to set up to run our service?
Yep, on the same specs. So our edge devices are very minimally provisioned. You can for 50 machines, up to 50 machines, we recommend 1.5 gigahertz to 2 gigahertz CPU. I think our edge devices are on like an Atom processor, so it's not a very beefy machine as far as that's concerned. RAM is about 4 gigabytes, and storage is 64. So if you stick to that spec, you can expect the same performance as our physical edge device. And then if you wanted something for more machines, you could either have multiple virtual machines or provision your virtual machine more robustly.
Like all that is to say, it's very lightweight. Usually when I tell people those specs, they're
Like, yeah,
blown
whatever.
away that that's all we need. They're like, oh, yeah, that's no problem. So we have a question. Is there any tools for scheduling and dispatching operations? Maybe I'll start with that one, because I see a couple more questions here, definitely for you, Jacob.
Sure.
But yes and no. So our product can automatically dispatch and create schedules for operations based on what programs are running. So it's what we call automated production monitoring. And we can look at what program is running through a couple different ways, either a header or a couple different data items. And the software will automatically start a job, create a job, clock into that job, record all of the data associated with that job, so part counts, alarms, cycle times, things like that. And then when that program changes, it'll automatically clock out of that job and create a new job and clock into it. Generally, what our customers will do is then they'll integrate MachineMetrics into their ERP or scheduling software, in which case now instead of the system automatically creating a job, it pulls a job from the ERP, pulls in all the information contained with the ERP from that, and in many cases even clocks in and out of the job in the ERP. So you can use MachineMetrics. Some customers will use MachineMetrics on its own to keep track of kind of scheduling or the way the schedules play out. But in general, people will use a different tool that we then integrate with. But within the product, you actually can schedule jobs, select dates, times, when you expect them to be complete, ideal cycle times, things like that. But that can be a little manual, and we strive for a more automated process that integrates with your ERP system. Next question. Jacob, what communication protocols are coming of age and what might be more security aware? MT Connect is old. Is it secure?
It's a great question. That's a great question. So MT Connect isn't actually a protocol unto itself. I'll get to some of the details on like what's coming of age, but MT Connect isn't a protocol. It's really a standard around the schema. It describes what data is coming off the machine. It's really the types of data that's coming off, the hierarchy of how everything relates. It's not the protocol. Though, as part of the MT Connect standard body, they have developed what is effectively kind of a standard, and that's the XML that gets output over HTTP. You can further bolster that. Not many people do. The truth is we're living in a world where there's machines that already exist that aren't going to be updated for a long period of time, and so they need to be they need to be supported. And those do have older legacy protocols that don't have the security side on them that they should. So keeping physical isolation of the network is paramount. So 2 other points. Once the data is into the MachineMetrics platform, all the ways that we expose the data to you are highly secure. They're either WebSockets, secured WebSockets with authentication, or HTTP requests and so on. So there's a number of ways that you can physically isolate legacy equipment, or really even modern equipment that doesn't have that security posture that you're after, from the rest, but then interact with the secure side. So that's part of it. Now, as far as what communication protocols are coming of age there's MQTT, is starting to gain popularity, but you don't see it in many, if any, piece of manufacturing equipment, especially in the CNC space. We just do not see it. But it is out there, and it is something to pay attention to. OPC UA as well. I wouldn't consider that new and upcoming, but it's certainly gaining popularity, and has full certificate support, similar to MQTT. And there's a bunch of other security layers that you can strap onto it.
As a follow-up question for that, Jacob, I know we build a lot of our own software adapters for particular machine controls. So Fanuc, Mitsubishi, Heidenhain, MachineMetrics has created customized adapters for those machines. Are those adapters that we've built more or less or secure than a standard like MT Connect?
Sure. I mean, there's a sense of security in their obscurity, I guess, right? In order to talk to a FANUC controlled machine, you need to know the FANUC protocol, where MT Connect is just HTTP, and you can pull XML data off of the machine. So in some respects, some of those protocols are, I can't say that they're more secure. They're just obscure. People wouldn't know that they're there or what they can do. But generally, no. But once you put our system as that layer in between the machine and anything that you want to interact with it, there's the security layer. MachineMetrics can act as that security layer.
Great. Another question probably for you, Jacob. I'm not sure I totally understand it. It says, does the application help manage report by exception prior to historizing?
Good question. So I can give you some examples. Like on the tool monitoring side, we're capturing data at high frequency rates, kilohertz level rates. And there's really no reason, if we had the appropriate model on the edge device, which in our pilot customers we do, there's no reason to send that high frequency data to our cloud. So the exception that we'll actually be sending out in historizing is tool failed. So that's a lot less data than a kilohertz sampling rate. There's a lot of data that we do capture that you might not leverage immediately, but having it there, and this sort of gets into that next point about how many tags and frequencies do we handle polling simultaneously, which I'll get to in a moment, is that you might find new use cases that could leverage that data in the future. And so it's not always guaranteed that you're going to make the right choices early on. So it's a balancing act between, do I want to capture everything and then figure it out later, or do I want to take a more measured approach and only capture what I know that I can leverage now? So that's a balancing act. So we try to do our best there, but there are cases where we do report by exception, and other cases where we capture data that we might not leverage right away. And then this next question, how many tags and what frequency could the gateway handle polling simultaneously? We capture data from most pieces of manufacturing. It's a big depends. It really depends on what type of equipment you're talking to. But we capture data at roughly 1 hertz from most pieces of equipment. For some use cases, we'll capture few data points at a kilohertz. Very few applications actually leverage that today. And then there are some pieces of equipment that just can't handle being pulled at 1 hertz, 1 sample per second per data point, and they're configured accordingly. It really depends on the capabilities of the protocol that you're communicating over. As one example, a FANUC focus controlled machine, we capture about 100 or so data points once a second.
But the hurdle here, or the bottleneck, is usually the machine and not the
Sure.
MachineMetrics gateway.
Right. Yeah, it's not really about the edge device, it's about the protocols. And in some cases, the protocol requires us to use a series of SDKs and tools that run on our edge device that also have their own performance implications as well. So not necessarily the power of the edge device. It's not always the machine. It's somewhere in between.
Great. Well, keep those questions coming. We'll give a couple more minutes if you have a question to type in. We've got time to answer them. I've got one more filler question here for Jacob, because I know this comes up often. So what if a shop has a particular security protocol or standard that they're trying to achieve, whether it's ISO, ITAR, something like that? How does MachineMetrics help make sure that those needs are met?
Sure. So we work with customers with varying security needs all the time, often through whoever their security consultant is. There's often a security consultant if there's a big effort to adopt a new program. And so we make sure that any data points that we feel might meet their standard for compliance are brought to their attention. And then we have a conversation about what approaches can be taken to address that. And it varies. It really depends on the business, what type of equipment they have, and what their needs are around the compliance program. But we work with them both through conversation, but also through providing them with our own certificates. So we have an ISO, like I mentioned earlier, an ISO 27001 certification. We can provide our customers with that, which is generally a great starting point. We'll also fill out security assessments as appropriate to make sure that our compliance program is compatible with their needs.
Great. Thank you, Jacob. Well, it seems like that's all the questions. So with that, I think we'll pull the webinar to an end. Again, if you have any further questions at all, feel free to email either Jacob or myself directly. We're happy to answer questions. You can also reach out to our team just through our website. There's actually live chat now on our website, which will put you in charge or put you in touch with somebody who can send you to the right person to answer your question. We'd love to help any way we can. So thank you very much for attending today's webinar. Hope you have a great afternoon.
Bye, everyone.